Good morning. So we've been looking at exponential growth in this unit, and within that we've looked at compound interest, how a bank would pay you money, or possibly charge you money if you're talking about a credit card type situation. And today we're going to look at a very important aspect of that, because as you mature and become a grown-up, you're going to have to make some financial decisions. And sometimes the information given about different accounts that you might be considering is given with different parameters, meaning that some banks will pay annual interest, some will compound daily, monthly, whatever, and there'll be different interest rates, and it's really hard to tell which one's going to be actually the best one for you financially when they're described in different ways like that. So what I'm going to show you today is really important. It's going to let you make fair comparisons between different offers that you may receive about financial situations. So what I have right here is two options that we're considering for a bank account. One is going to pay 4.24% interest, and that's going to be compounded annually, so that means just one time a year. And then option B is going to be 4.18% interest, but it's going to be compounded every day. That would mean 365 times in a year that would be compounded. So it's a little hard to compare these. Like at first glance, you might be like, oh, I'm going with A because it's a little bit higher interest rate, but they're only paying you that once a year, and that's going to affect things. So let's just see where this goes. So these are going to be using our equation from yesterday, where the value of t, remember that's like our output, our y, the value at time t is equal to the principal times 1 plus the rate divided by the number of times per year it's compounded, and then our exponent on that is going to be n times t, where n is that number of times per year it's compounded, and t is the time in years. Okay, so that's what we're going to use for both of these. And let's look at them separately. So we'll look at option A over here. So we'll do A in green. And then we'll look at option B over here in blue. Okay, so for option A, the value at time t is going to be, now do we know a principal amount here? Does it tell us how much money we have? No, so I'm just going to leave that a P for now. 1 plus the rate. So that rate, what's the rate for option A? See that 4.24? Now, I know you see a decimal point in it. We still have to slide that decimal point over 2 places. So we'd be talking a 0.0424. I'm going to add that, okay, so let me write that down. 1 plus 0.0424 divided by, what is my n value? How many times is it compounded a year in option A? Just that one time a year because it's annually. So that's over 1. And then for my exponent, it would be 1 times t. So I've got everything filled in there. So now let's do a little bit of simplifying. So v of t will equal the principal, whatever that is, how much money I start with. In the parentheses there, that's going to simplify to a 1.0424. And then for the exponent, 1 times t is still just t, so I can write that to the t power. Okay, so that's a little bit simplified, cleaned up version of that one. So I'm going to hold that thought on option A, go over to option B for a little bit here. So for option B, the value at time t, I still don't know the principal, so I'm still going to just use a P to stand for principal amount. 1 plus, okay, now my interest rate for option B, what is it? You see that 4.18? Slide the decimal over 2 places, so it's going to be 0.0418. And this time, I have a different n value. N is how many times it's compounded in a year, and this says daily, so how many days are there in a year? That would be 365. So I have an n value of 365 here. And then my exponent needs to be n times t. So that would be 365 times t. Okay, so there I've got everything filled in for my option B. So now let me grab my calculator, and I'm going to start in the parentheses. So I'm going to take my 0.0418 and divide that by my 365. I get a decimal. I'm going to keep this decimal on my calculator, all right? I'm not going to round it. I'm going to keep it there, and I am going to add 1 to that because of the 1 plus whatever. So I have v of t equals p times 1.0001 4 5 2 1 to the 365th t power. Okay, so now I want to think about my exponent. I have 365 times t. I'm multiplying two things in my exponent. When do you multiply with exponents? What rule or law of exponents makes you do that? That's when you would have a power to a power. So I can set this up like so. I can say that I have the 1.001, that number, to the 365th to the t power, because if I have a power to a power like that, I would multiply the exponents, the 365 times t, and isn't what the previous line had said? 365t was my exponent, so I'm going to evaluate that part in the red bracket. So I'm going to raise what I have on my calculator to the 365th power, and I get 1.04268, etc. So let me write that down here. So v of t equals p times, so now I'm going to put, oops, that's supposed to be red. What's in that red bracket now is a 1.04268. There's a few more digits after that, but that's enough that I'll be able to compare to what I have in green. So I'm going to stop there for writing. To the t power. Okay, so now I want to make a comparison here. I have that a little bit simplified. So I want you to look at what we have in green here for option A and what we have in blue here for option B. So we're finding the value at time t in both of them. After the equal sign, you see a principal. That principal amount, how much money you'd put in, would be the same in both. Like I have so much money, I want to invest it in one of these accounts. So that's not going to affect which one's a better deal, okay? And then they both have some number raised to the t power. So I want you to compare the sum number part. So look at this number, the base of my exponential function here. I have in green a 1.0424. In blue, I have a 1.0426. So the blue one is a slightly higher number, which means that one is going to earn me a little bit more interest. So option B would be the one to choose here. It's going to earn you a little bit more interest, and that's good if it's money that you're earning. Now, if this would be a credit card, you'd want low interest, but this, I said, was a banking account, so we want high interest, and so that's the one that you would choose, is option B. It has a slightly better rate. So again, I couldn't compare them just straight up to begin with because they had different rates at which they were compounded, but by making this section right here where I looked at the exponent, that 365t, as 365 as the exponent raised to the t power, that gave me a block in that red bracket of purely numbers. If it's purely numbers, you can just use your calculator and calculate it. And then, since we had parallel setups there between the last line in green and the last line in blue, we were able to make that comparison. So that's what you're going to be doing today, is changing simplifying basically the compound interest formula so that you can make comparisons and decide which one would be a better deal. So let me know if you need help, and remember that Jesus loves you and so do I, so do your math.